So welcome back to today's lesson. We looked at trigonometry in our previous lesson, and I hope you didn't forget. What did we cover? What is trigonometry? Okay, very similar to Pythagoras, which we've already looked at. Okay, between Pythagoras and trigonometry, Pythagoras uses the length of sides in a right angle to find unknown sides. Whereas when we are looking at trigonometry, we use the angle inside the triangle to find the missing side or the unknown side. Okay, now we looked at the sine ratio last lesson. This week we are going to look at the cosine ratio. Okay, so cosine ratio, let's put that up. Before we get into the cosine ratio, let's review parts of our last lesson. Okay, we have here two right angle triangles. I'll put up two. And remember theta, theta represents an angle inside the right angle. Okay, we use that when the angle is unknown. All right, so theta here, and let's determine the sides of our triangle. All right, remember we named the sides of our triangle according to the location of theta. So in this triangle, this side is opposite, okay, and this side here is the adjacent side. All right, now if I move theta to the other complementary angle up here, okay, now theta has moved from this corner to the top end there. When theta is in that corner, this side is now the opposite, and this side is now adjacent. Okay, so don't forget that. Keep that in mind. We looked at the sine ratio last lesson. Okay, and the sine ratio, we use that when the unknown side was opposite the given angle. All right, here, let's just say that's x. Okay, so we use the sine ratio. Okay, sine theta equal to opposite over hypotenuse. All right, so we use that ratio when the side opposite the given angle was unknown. Okay, now today in the cosine ratio, rather than the opposite side, we are now going to look at the adjacent side. Okay, so let's have a look at our triangle. Again, you might get tired of the triangle, but it's a beautiful shape. All right, so in the cosine ratio, we are going to find the length of the side that is adjacent to the given angle. All right, so cosine theta is equal to this time adjacent over hypotenuse. Okay, so unknown side is now the side that is adjacent to the given angle. All right, now let's have a look at a couple of examples so that we can see how to apply the cosine rule to find that unknown side. Okay, now let's see. Example number 1. A triangle. All right, make sure it's right angle. Our given angle in this case is 35 degrees. Okay, and our hypotenuse is 9 meters. Okay, The unknown side is this side. Okay? Now, before you work it out, because you've already learned about the sine ratio, to make sure that you are using the correct ratio, you label our sides here. This is the hypotenuse, and this x is sitting here where the adjacent side is located. Okay? So, we should already know if adjacent is the side I need to find, then I'm using the cosine ratio. Okay? So, let's work this out. Cos theta is equal to, what's the unknown? X over hypotenuse of 9 meters. Okay? Now, in place of theta, we're going to put our given angle. Cos 35 degrees is equal to x over 9. Now, similar to how we worked out sine ratio in our last lesson, the same approach is taken here. We bring 9 across to this side. Okay. Remember, when you divide, you multiply on this side. So 9 times, okay, cos 35. Now remember our trig tables? That is what you are going to use to find the value of cos 35. However, you must be careful. The first column in the tables is the sine column. Cosine column is the second column, so make sure you're looking in the right column to identify cosine value of 35 degrees. Okay, so cos 35 from my tables here is 0.8192. Okay, equal to x. Now, again, when there are numbers inside the brackets, we are multiplying. So 9 times 0.8192 equal to x. Multiply. Okay. Let's come back to this end here. Remember, when you are multiplying with decimals, you need to be very careful. 8192 multiplied by 9. Okay. Let's see. 9 times 2 is 18. 9 times 9 is 81 plus 1 gives us 82. 9 times 1 is 9 plus 8 is 17. Okay, 9 times 8 is 72 plus 1 gives us 73. Okay, now we have 4 decimal places here, so we need to move the decimal place 4 times in this direction. That brings our decimal there. Okay, so we have 0.8192 times 9 is 7.3728. Okay, we come back to our answer here, 7.3728. Go back to your triangle to make sure you're using the right measurement, which is meters. Okay, equal to x. All right, so we've looked at how to use the cosine ratio. You will see if you are asked to round off this answer, then you round it off. Otherwise, you leave the answer as it is. So the length of x, or the adjacent side in our triangle, is 7.3728 meters. Okay? Now, in our next segment, we will look at a practical example of cosine ratio, and that should be interesting as well as this one. Thank you.